Hey team, welcome to this explainer. I really wanted to bring us all together today for a vital mentorship discussion. Look, as your engineering lead, I watch you build robust, highly functional enterprise applications every single day. I know exactly how capable you all are. Yet I also know that whenever the conversation shifts to abstract data structures and algorithms, well, a lot of us just tense up. So the goal of our session today is to completely shift our mindset away from that grueling, exhausting process of memorization, and instead, we're going to embrace something called structural algorithmic reasoning. Honestly, we're going to change the way you look at code forever.
How can I be a real engineer if I struggle with LeetCode? Now, I know for a fact that this specific imposter syndrome plagues even the absolute best developers on our team. But I want to validate something for you right here, right now. Struggling with complex algorithms is a translation issue. It is not a lack of talent. You already have all the engineering logic required. You've just been taught to translate that logic using a deeply flawed educational model.
All right, so here is our blueprint for today. We'll cover 1. The Pattern Dependency Trap. 2. The correct code framework. 3. Procedural versus structural learning. 4. Curing developer imposter syndrome. And 5. Thinking like system designers.
Let's jump right into section 1, the Pattern Dependency Trap. Okay, so the biggest culprit here is something we call pattern dependency, and it's a really dangerous illusion in traditional instruction. Think about how algorithms are usually taught, right? You're shown a problem, you're taught a specific trick, like say 2 pointers or a monotonic stack, and you're just expected to memorize it. You do this hundreds of times, and what you end up building is this chaotic mental evidence board of totally disconnected patterns. Then you sit down, you face a slightly unfamiliar problem, and you freeze. Why? Because you're desperately searching that mental catalog for a matching pattern rather than actually understanding the underlying structure of the problem right in front of you.
The sheer mental expense of that old way is just punishing. I mean, you need massive exposure to hundreds of problems, endless memorization, constant reinforcement just so your skills don't decay. And then you try to recall that exact pattern under extreme pressure. Building this giant, fragile lookup table in your head is an incredibly inefficient process. And that's especially true for late learners, career changers, or busy mid-level developers like yourselves who simply do not have the time to go grind hundreds of random puzzles. You need a system that relies on reasoning, not an encyclopedic memory.
Which brings us to section 2, the correct code framework.
So the crucial point here is that we are completely reframing computer science. We are taking it from a collection of isolated puzzle tricks and turning it into a logical system of movement and constraint handling. The correct code framework introduces what we call decision architecture. Instead of looking at a problem and asking that total dead-end question, what pattern is this? We're going to teach you to ask, what structural conditions exist here, and what decisions logically follow from them? It basically treats every single problem as a navigational challenge. Information enters the system, constraints shape its movement, and your decisions determine exactly how it's stored or transformed.
Think of it like this. The framework acts as a massive conceptual compression layer, dramatically reducing your cognitive overload. Instead of trying to memorize 300+ disconnected coding patterns, we compress all of that complexity into just a few universal reasoning primitives, things like traversal, state retention, partitioning, and indexing. Once you understand these 4 or 5 foundational pillars, you can derive the solution to almost any problem. Because again, you're analyzing structure. You're not frantically searching your memory for a matching template.
Let's look closer at this in section 3, procedural versus structural learning.
Procedural learning is probably what you're most used to. It's super rigid and command-based. Use this technique here. Memorize this setup. It's essentially just flashcards. Structural learning, on the other hand, is all about adaptive deductive reasoning. It asks you to understand the forces acting on the problem and to understand the actual movement of information. Structural learning gives you the exact tools to figure out the answer, even if you have literally never seen the problem before in your life.
Let's look at a really concrete comparison to make this clear. We all know binary search, right? Traditionally, it's taught as a memorized trick with a very specific while loop template. But under this new framework, binary search is an architectural deduction. It's defined as ordered elimination through certainty reduction. So you aren't memorizing a trick. You're utilizing the fact that the data is ordered to systematically eliminate half of your uncertainty with every single step. Same thing with a sliding window. It isn't just some quirky loop. It is controlled boundary movement under constraint. When you start viewing algorithms this way, the underlying logic suddenly makes perfect intuitive sense.
So to get to that level of deduction, there are specific structural questions you need to ask when you face a new challenge. You basically want to map out the problem like a detective verifying clues. Is the information static or is it changing? Is your traversal linear? Is it branching? Cyclical? Are the decisions you are making reversible? By just asking and answering these questions, you naturally deduce the required data structure and algorithm. We are completely replacing the guesswork and the rote memorization with pure logical deduction.
All of this leads us perfectly into Section 4. Curing developer imposter syndrome.
I want to repeat this because it's so incredibly important. Algorithm struggles are a translation problem, not a talent problem. You are all experienced developers. You architect complex APIs, you manage infrastructure, you build incredibly functional apps every single day. If you freeze on an abstract coding challenge, it simply means you lack the structural translation layer. That's it. Those experienced engineers who seem like algorithm wizards, they aren't doing magic. They are just unconsciously using internal decision frameworks. This new approach simply takes those hidden mental processes and makes them totally visible and accessible to you.
The psychological difference between these two approaches is literally night and day. Think about memorization-based confidence. It's incredibly fragile. Under that old model, unfamiliar problems are terrifying, and forgetting a single pattern during a whiteboard session feels like a total catastrophe. But look at the alternative. Reasoning-based confidence is completely durable. Unfamiliar problems simply become navigable landscapes. Adaptation is possible. And most importantly, that confidence is actually transferable to your daily engineering tasks. This shift is the absolute cure for imposter syndrome.
And that takes us to our final topic, Section 5, thinking like system designers.
When we finally strip away all the dense academic jargon, algorithms are really just systems. That's all they are. They're systems of movement, state management, constraint handling, information flow, and decision orchestration. Now think about your day-to-day job for a second. These conceptual anchors are the exact same principles we use when architecting large-scale enterprise applications, right? Designing a scalable microservice architecture requires the exact same thought process as solving a graph traversal problem under this new structural framework.
And that brings us to the ultimate realization here. Training in classification, decomposition, and reasoning makes algorithmic thinking feel connected to real engineering again. It takes all these concepts completely out of the realm of trivia and puzzle solving, and it places them firmly back into the domain of software architecture. By adopting this framework, we aren't just getting better at solving abstract LeetCode problems. We are becoming deeply effective system designers, which ultimately drives our developer velocity and scales our team to entirely new heights.
I'll leave you with this final provocative thought today. As you continue to grow in your careers, you really have a choice in how you learn. Ask yourselves, are you building a fragile lookup table of trivia in your mind, just hoping you remember the right trick at the right time? Or are you building a durable architecture of understanding that's actually going to scale with you for the rest of your engineering career? The choice is yours, team. Let's abandon the memorization trap for good and embrace the long-term cognitive transformation of structural reasoning.